Here's 12.4, overlapping events. So I'm going to be looking at overlapping events through the lens of Venn diagrams. There's these diagrams with the circles. So we've got inclusive events. These are also called jointed. These events overlap. Okay, so if we're talking about playing cards, maybe my first category here is queens, and the second category is hearts. And there is a card that falls into both of those categories. It would be the Queen of Hearts, right? The Queen of Hearts would be in that overlap. Whereas if I had, let's say, queens and kings as my two categories, there are no cards that are both of those. The card could be one or the other, but not both. So these events do not overlap. And it's also called disjointed. Okay. All right. So let's look at an example. I've got these two categories, athletes and musicians, and there is going to be some overlap here. There are going to be people who are athletes and musicians. Okay, so it says 39 students are surveyed. So that's the total. Let's start breaking this down then. It says 20 of them are athletes. So I'm going to put 20 right here for the athletes and 18 for the musicians. Okay. Now we can figure out the amount of students that are in the overlap group because it says 2/5 of the athletes are musicians. Okay, so hey, there are 20 athletes, right? So I can say that 2/5 of 20 is going to be the musicians, the musician athletes. Okay, so let's find 2/5 of 20. If I want 2/5 of 20, I'm going to do 2/5 times 20. And you could think of that as 20 over 1. So that would, if you multiply straight across, you get 40 over 5, which is 8. And that is that crossover group. So this is going to be 8 students in here. Okay. Now that I've got that crossover group and that overlap group, I can fill out the rest of this Venn diagram. So if I look at just this circle, I've got 20 total in the athlete circle. 8 of them are here. And then, so 20 minus 8, that means there's 12 students in the that are athletes but not musicians, right? And we can do the same thing over here. If I look at just this circle, the total is 18. I've got 8 in that category, so 18 minus 8, that means there's going to be 10 students in that spot, okay? So then we've got one more group because we've got students presumably that are not athletes and they're also not musicians that are in the surveyed group. So let's think about the total. We've got a total of 39 students. Okay. So if I'm trying to figure out, I'll call it the neither category, the group that's outside of both circles. I'm going to take my total and subtract out the athletes and musicians. Okay, I'll just put A and M for athletes and musicians. But the thing with this, if you count up, if you add up the 20 and the 18, that's going to be 38 students right there. Means it'd be 39 minus 38, so there'd only be one student outside. But if you do it like that, then we've double counted those 8 students who are in both groups. So when I'm figuring out the athletes and musicians, I actually don't want to do, well, the total's 39, but what I don't want to do is this. This is incorrect, okay? What I want to do instead is take my subcategories and add these up. If I do 12 plus 8 plus 10, then I'm only counting that 8 once. I'm not counting it in both groups. Okay, and then if I add 12 plus 8 is 20, so 20 plus 10 is 30. I've got 39 minus 30 then, and I worked myself into a corner here literally. All right, but I've got 9 students then in that neither category. So I'll put that up here, okay. So I've got 4 different groups now. I've got this group, that group, that group, and the neither group. And now I should be able to answer any probability questions I get here. So probability, I'm always thinking probability is going to be the favorable number of favorable students over the total amount of students in each group, okay? So we're saying if a student from the survey is randomly selected, so one of these 39 students, what's the probability that they will be an athlete and a musician? So the favorable region would be this overlap, right? These are my athlete musicians in here. So there's 8 students that are in that favorable category out of a total of 39. And I'd want to reduce that, but that one is reduced. And you could also write that as a percentage if you liked. But I'm just going to leave these as reduced fractions, okay? It's a different question when I say what's the probability that a randomly picked one will be an athlete or a musician. So, because that means everyone in these circles is going to be either an athlete or a musician. And yeah, those ones are both, but they would be favorable as well, right? So when I'm looking at the favorable here, I'm going to take everyone inside of the circles. And I don't want to just add 20 and 18 because then I'm double counting the 8 in the middle there, okay? So it's always going to be out of 39 students here. So now I've got, let's see, that's 30 out of the 39 students are going to be in one or the other category there, okay? And this one I can reduce. 3 goes into both 10 and 39. So if you divide top and bottom by 3, you get 10 over 13, okay? All right, and then finally, let me zoom out here a bit. Probability that a student is not an athlete and not a musician. Well, that's the neither category, right? These 9 students are not athletes and they're also not musicians. So it's 9 out of the 39, and again I can reduce by 3 here. That would give me 3 over 13. Okay, so most of the work comes from filling out the info on the Venn diagram, but once you get that in, you just look for the favorable groups over the total amount. Okay, let's try another on the next page. Same kind of problem, new survey. We've got athletes and musicians again. This time there's 40 total students surveyed. 15 are athletes and 12 are musicians. Okay, I'll put that in a little diagram here. All right. And then we have 1/3 of the athletes are musicians. So 1/3 of the athletes are musicians. That's how I'm going to figure out what goes in this overlap group. It says 1/3 of the athletes, that's 15 students, should be in this overlap group. So I can say 1/3 of 15 here. So 1/3 of 15, 15 divided by 3 is 5. That means there's 5 students who are both athletes and musicians. Okay. All right, so now I can figure out these two groups. If I'm looking just here, 5 plus something equals 15. That's got to be 10, right? Or I could just do 15 minus 5. So there's 10 students here, okay? And I can do the same thing over here. 5 plus something equals 12. So this is going to be 7. All right, or you could take the total minus 5. Okay, so I've got those groups now. Now let's figure out how many people are outside of these two groups from the 40 surveyed students. So if I'm looking at the neither group, I want to take the total and then subtract out my athletes and musicians. Okay, and it's tempting always, here's the big mistake, it's tempting with athletes and musicians to just add up these two larger groups, but this is going to be incorrect, because if you do this, if you do 15 plus 12, you're saying there's 27 students who are athletes and musicians, but you've double counted the 5 people who are both of those things. So you don't want to do that. This is incorrect. What you want to do instead is add up the subcategories. Okay, if I just add 10 plus 5 plus 7, then I've only counted those 5 students once. Okay, and then let's see, that's going to be 15 plus 7 is 22. And then let's see, we've got 22. Got 18 then students on the group on the outside. Okay. All right. So now let's answer the questions here. If a student's randomly picked from these 40 students, what's the probability that they will be an athlete and a musician? Okay, so I'm going favorable over the total. So the total on all of these, since we're picking someone from the whole group of 40 students, it's going to be a number over 40 for all of these. So I just wrote those in. I was zoomed in too far, but total's 40 on all of these questions because that's how many total students we're dealing with. Okay, so we want what's the probability that there will be an athlete and a musician. Well, that's the crossover group. There's my athlete musicians. There's 5 out of the 40, so that would be 1/8 reduced if you divide it by 5. Okay, an athlete or a musician. So it's tempting here to say, okay, I'll take the athletes plus the musicians over 40, but this is incorrect because then again we're double counting the 5 who are in both groups. So it's better to add up these subcategories. I'm going to do 10 plus 5 plus 7. Okay, and that's going to give me 22 out of the 40. And then I can reduce that. That's going to be 11/20ths because they're both even numbers. I can divide by 2, and that one is reduced there. Okay. All right, and then zoom out here. Probability that a random student is not an athlete and not a musician. So that's going to be the neither group, right? So I've already figured out that neither group is 18 out of the 40, and now I just need to reduce that. And they're both even numbers again, so I know I can divide by 2, which would give me 9/20, and then that's totally reduced there. Okay. And then what's the probability that, last one here, that probability that a student is a musician but not an athlete? A musician but not an athlete. Okay, so I'm thinking who's the favorable ones? We got our musicians here, but we don't want an athlete, so those 5 in there are also athletes. So our favorable group then would just be those 7 out of the 40, and that is reduced, and so we are done. 7/40ths, and that's the end of the section, and I'll see you next time.